Hi, everybody. I'm Alex. I'm here with my colleague Dylan, who's just sitting over there, actually. We've come all the way from New Zealand to tell you about our experience of using AWS and really transforming how we manage and use data within our organization. I've got to say, it's highly unusual to travel overseas from New Zealand in the middle of winter and end up somewhere that's colder. So, that's blown my mind. So this is really a bit of a case study, I guess, in practice about stepping through some detail in terms of what we actually did and where we started from. So a bit of context. We are a GP-owned, run, governed, managed primary care network in the North Island of New Zealand. We're a non-profit. We provide primary care services to our patients. Been running for about 30 years. We currently look after around 500,000 patients, which is quite a lot for New Zealand. Three parts to the company. The network, we have the GP network, we have a provider arm, Midlands Health Network, and we work in Ventures, which do a lot of our work around improvement and innovation. So that's where we come from. But within Ventures, there's a few subsidiaries which are quite interesting. We actually directly own a number of practices. We currently run 12 practices with about 60,000 patients. So we have direct access to anything that happens in those practices, and we can roll out and test new models of care and all kinds of interesting things at those sites. We do hosting and infrastructure support for most of our network practices and some external ones too. Some work around models of care, as I mentioned. We're running a pharmacogenomics program now as well called Ventures GX, and we do some consulting. My boss was here in Brisbane last week talking about the healthcare home model. So that's where we operate, kind of most of the Midland region in the North Island of New Zealand. I don't know why I'm looking here, because I've got a screen here. But you can see that we've got a pretty high proportion of rural patients and practices in rural sites. We actually have a proportionally higher proportion of Maori and Pacific Island patients within our network. So some of the public health chronic disease issues that are associated with those groups. In terms of our data, so the starting point really was just, I don't know if anyone here can empathize with this, but we just had this accumulating mess really of on-premises database, just horrendous stuff going on. Staff turnover, no documentation, we brought people in, they sort of didn't want to touch what was already there because it looked so fragile and it was a bit scary, so we built more stuff on top of it and it just ended up in this huge kind of house of cards. So pretty ubiquitous problems in health, I suppose. We've got lots of data from different sources, and the volume and complexity of it is increasing because we have changes to service contracts, new government health targets, all kinds of stuff that we really need to adapt to very quickly. And some of the problems we have, I don't want to say SQL Server in a local data center is a problem per se, but like for us it was. Lots and lots of stored procedures. I've got my 12-year-old daughter to help me out with the text there, so not a billion, but lots and lots. Documentation problems I've already mentioned, and it was just getting really expensive. So we were kind of locked into using a local data center provider, and we need more storage on this server. It's a business case. It's 11 solution architects. It's thousands of dollars. It just became really difficult to deal with. So we needed to do something different. Some additional things that we're just playing with in parallel to this. So what we really want to move to is the ability to take data directly from the practice and land it into our data store without any management or manual intervention. So 8Wire, a New Zealand company who are approved by the New Zealand government to share data using their product across central government agencies, and we're finding that that's really a powerful tool as well. We heard a bit earlier around openness and accountability. So something that our members haven't had. I don't know what the situation is like in Australia, but there's lots of third-party tools that are hooked into primary patient management systems, and our GPs were kind of saying we don't have a lot of visibility over exactly where that data is going and what data is going where. So 8Wire gives us the ability to really transparently present the data that's going out of each practice, and our GPs really like that. Of course, this is a thing that's happening, so we want to start tying in more patient-generated health data. Like I said, we own a number of practices, so our patients are saying, I want you to take in the data from my continuous glucose monitor or from my whatever wearable it is, and to integrate that into my health record, so we need to start to deal with that. I mentioned genomics as well, so we're going to start to bring in lots of that data into our own platform. Currently, we're working with an Australian provider to do that for us, but we want to kind of push that forward because this is an area of real opportunity for us, I think. Well, not for us, but for our patients. And just generally, we found with the setup that we had before, I talked about the complexity and the issues that we had, it just became really difficult to flex where we needed to, and to have really, really strong, clear, and accountable oversight of who was using the data, where it was going, what was happening. And also there's lots of really interesting opportunities we're developing with our research organizations and other people. And we just found that the tools and products that we were using didn't really give us the ability to safely and securely manage that and control it. And that was another advantage that we saw with using AWS. Actually, we can now share more data, but do it more securely. So we had a few things happening in parallel. We needed to change this. We knew that step one, my boss was really, I don't know what the adjective is, but he wanted to go to Las Vegas, basically. So let's go to reInvent. So we did that last year. So this is as recently as last November. And we had zero real exposure to AWS prior to that point. 2018, November, we went to Las Vegas. Everyone was kind of like, oh, you're going to Las Vegas. And I mean, it was brilliant, but like we were literally like in those dark rooms for 5 days. We learned lots. It was a really amazing experience. And it kind of really solidified our thinking, I guess. We heard from people, kind of like you do at these summits here, people saying, we're actually using this stuff, we're actually building data lakes, we're actually doing this stuff in real life. It's not some high-level presentation. You have to kind of see, well, actually what's happening. So that really kind of fired us up, I guess, to think that we could really do this. So again, a bit of courage from my boss. He said, well, we've got some real embedded business processes in this SQL Server thing. We've got DBAs who want to, stick to their database, which is fine, but we kind of had an impression that they were going to be really hard to shift in such a different direction, I think. So what we did was we developed another team which didn't really sit in any business as usual capacity at all, so they had the freedom to just start building this stuff, which I think is one of the reasons why we managed to get ahead so quickly, but a real luxury. Also, I think in the last presentation we started to touch on resource or human resources, and I think this is a really big thing in my mind here. We advertised for 2 positions. Dylan's one of our data engineers. We put the ad out on Christmas Eve, and everyone was like, oh, that's really stupid. No one's going to apply. It's Christmas, everyone's on holiday, they're at the beach. And traditionally, it's been like that. But we put the ad out, and we did it sort of along different lines than we would usually do. We kind of made it real competency-based, whereas traditionally, you end up with a bit of a laundry list of things you need, and it can be quite tight. And, I get that there's a need to do that because you have to have the integrity with certain tool sets and things. But I think we found that by kind of pulling away from that, it really opened the door to a lot of people that wouldn't necessarily have fitted that very tight definition otherwise, and we were really swamped with applications. It was a really interesting experience. And so the 2 people we were really fortunate to end up with, 2 young men, Dylan's here, as I mentioned. So they're very smart computer science people, but they had no experience of AWS specifically as a platform, and they had no experience in the health sector. So these are 2 things sort of I want you to remember, because we gave them the freedom to run with this, and 4 weeks later, we had what was version 1 of our current data lake, which Dylan's going to talk to you about in a bit more detail.
Hello, I'm Dylan. I'm one of the new data engineers that got hired by Ventures. It's a real privilege to come here after 5 months of being a fresh engineer, to come in and talk about what me and my colleague developed. So this was our base for our proof of concept of our data lake that we developed in about 4 weeks. We used the AWS Glue service as our workhorse. So we used Glue to crawl the data and create a data catalog, which allowed us to directly query the objects in the S3 buckets instead of putting it into a traditional database. And we also use the Glue jobs as our ETL functions. As you can see, we use a 3-stage data lake where we land all of our data into a raw data bucket. We then process it through to transformed, getting the correct data types, and process it further into enriched, removing personally identifiable information and making it query ready. At a very high level, I thought I'd just get into what Glue can do. So if you've got a basic CSV data file, you can just throw it into an S3 bucket. You can create a data crawler using the Glue service, and then when you run it, it will create a table for the CSV file. You can then use Amazon Athena to directly query that file in the bucket without placing it in a database at all. You just have a raw text file sitting in S3. So we can see we got 100 data count. We can now completely get rid of the crawler as it's already created the schema and just throw in additional CSV files of the same type. And we just get the data coming through from our queries in real time. So it's a very quick turnaround with little to no ETL at this stage. Here's a couple of screenshots. So here we have a bucket with a single CSV file, and we're just getting the count of the rows. Got 1,000 rows there. And we run a query a few seconds later after putting in a new CSV files, and we can see the row count has already jumped up to 1,500. So that's little to no time at all. We also build out our entire system in CloudFormation, which has been talked about a little before. So it's our entire data lake infrastructure as code. We write it as a YAML code document, but you can also write it in JSON. It allows us to build out our data lake in multiple environments. So we have a production and we have development environments currently. So we can spin it up and spin it down at no additional cost. We only pay for the actual runtime of those environments. Allows us to have a full visualized view of our resources at any time, so we can see exactly what we're using. So if we see a resource is underutilized, we can just get it out. And it also allows us to set up our security in multiple ways. So every time we run it, we have our security set in, we have our encryption on our buckets, we have our IAM policies for our resources. We've even started using CloudFormation for certain user groups to access the data that they need to access. So here's just a little diagram of our proof of concept, CloudFormation. So this is generated by AWS. I just moved it around a little. You can see that we use lots of glue jobs. We used one glue job per data type and then triggers for automation. And then we used Amazon SNS, which can send us emails whenever an error occurs or it's the wrong data type or just something happens. But we didn't stop there, we moved on. We moved away from using glue triggers and we moved to using AWS step functions, which allow us to fully visualize our entire workflow from our Lambda functions, which we use for sorting and data checking, all the way through to our glue ETLs and notification states. So you can see here, there's 3 sections of this current step function. There's a sorting and checking. There's the ETLs, so this is our raw to transformed ETL, this is our transformed to enrich ETL, and then there's some end states. This is an actual diagram generated by AWS from the raw code, and when you run it, and you can run this automatically or on a schedule, you can see it go through in real time, the entire process, and you can see the output and input of each state. So you can see it happening in real time. You can actually see if you've got any errors or any difficulties that come up, and you can intervene, and you can also set it to send you emails and notifications when they occur. So we actually have this running in the background currently. We just get an email every time it completes or if there's an error. We also use PySpark glue scripts. So for the glue jobs, we write it in PySpark and import it in. We moved away from using different glue jobs for our different data types, and we instead use a single PySpark package. We then set up what we call data dictionaries, which are basically just Python dictionaries that tell the glue script what to do for each data type. And this is really good because It makes it simpler to read, simpler to write. You can just go in and understand it. You don't have all of these stored processes in weird places, and you know exactly what's happening to each data type. And if it encounters a data type it hasn't had before, it will just generate a default script that's easy to edit later. When we first generated this, AWS hadn't put out bookmarking for Parquet files, which we use a lot for our compression. Bookmarking is used so we don't run the same ETLs on data that we've already processed and don't need to process again. So we've created a custom bookmarking method for all file types that allow us to basically save on time and cost. We keep this in even though AWS has their own one, because we also use it to dynamically assign our data processing units to our glue jobs. So this balances speed and cost. So we don't always need it done really quickly, but we need to get it done in a relatively good time period. But the more workers we put in, the more we pay. So we balance these two with our dynamic assignment based on the file types and file sizes. We've also spent a lot of time on our notifications, so we can get errors from every piece of code. If anything goes wrong, it will still pass through. Say if one data type fails, but the rest succeed, it still pushes through, but will send us a notification to this fact. So this is our more updated CloudFormation template for our new one. You can see that we've got a lot less in the glue jobs and glue triggers, but we now have a nice, tasty Lambda function state machine to do all of our processing. And this is really fun and really automated, and we hardly have to check on it anymore. Sweet. I'll pass you back to Alex.
Okay, cool. We've got our data in a data lake. That's great, but people still want to use the data and do stuff with it. So we're going to talk a little bit about how we use it now and the other tools that we can call on. But just to clarify, what we're really enjoying about this compared with our previous state, so this is completely serverless, so we've got no machines to look after anymore. That's good. That's to scale. So we've actually down to 10% of our previous costs, like 10%, it's insane. Yeah, we can automate everything. As Dylan mentioned, you can bring up the whole stack in a flash just by running it, put a different prefix, you've got dev, test, whatever you want. And everything within that stack is automated. So as long as you stay on top of the automation and don't go too far on working on the automation. So you get kind of meta automation. I don't know. CloudTrail is amazing. So I've never really been into logs before, but CloudTrail has really blown my mind with this. So every single action in AWS, we talked about security and transparency, everything's logged. Any API call you make is creating another new JSON file in your S3 bucket, which creates your logs. So for one production workload we've got running, you'd have a bucket, it's all separated by date. You'd have 200,000 plus logs, for example. So great, everything's there, but how do I access it? So of course, we can go back to this data lake concept. They're all just files in S3. You can run a crawler, you can build a database, and then you can query it, and you can look for code like this. You can just say, okay, well, tell me anything that Alex has done, and you get the results. And then you can filter that by the API action, whatever it might be. And you can automatically then, you've got really good insight into your logs, which, well, when I said I was excited by logs, I mean, I'm not excited by them, but it's really great to be able to dig into the information you need if you have a question, and to be able to go to your board and say, we've had this many API requests for this particular thing, or people have been accessing this particular bucket, to be able to proactively offer that information. It's amazing for them. And just a really great capability in terms of making sure that your permissions are doing what you want them to do. So in terms of using the data, so these are just AWS services that we now are really easily able to call on and just connect because they're there, and it's really easy, and you only pay for them when you use them. So this would really have been totally out of the reach of us previously. Alexa, we've heard a bit about Alexa before, but we're trying to think, well, what are some new ways that we can give people access to our data? And this was something that came out of reInvent, was a company who were letting people query business data using voice. So not like a ginormous use case for that, but there's definitely a group of people who would really value that. And we talked to some of our doctors, and they were like, well, yeah, sometimes when I just want the answer and I can just ask a question about, I don't know, how many patients have I got? So this is a skill that we built that does that. How many patients have we got in this practice or in this area or in this region? Just if you're on your way to a meeting, it's a really quick, easy way to do that. So that's useful. And we can also, this is another skill, sorry, the picture's not that great, but we can then filter that by the practice, I don't know what you call them in Australia, surgeries, I don't know, wherever they're enrolled as patients. So you can see how many Maori Pacific Island patients have I got enrolled in this practice, and you get the result instantly. And as Dylan mentioned, if we just keep that data store updated in S3, we don't need to do anything. We've always got the most up-to-date information that you can access via voice. So it's very powerful. Comprehensor is this natural language processing tool. AWS have got a medical-specific version of it, which is really exciting, and I think there are lots of improvements coming out on that this year. But again, natural language processing is really something that we wouldn't have been able to access previously. This is a made-up example. I mean, I haven't got gout, but it gives you an idea that you can just chuck free text data, unstructured data at it, and it will search through it, and it will identify the entities, the diagnoses, and medications that are contained in that data. And what we found, because of the difficulties we had with our previous database-centric environment, was that we've got 30 years worth of data on a total of about 2 million patients and all of their free text consult notes. And we were dropping those, but they were not getting loaded into the database because it's a large data field and nobody knows what to do with it, and it comes with some weird RTF symbols in it, and it's a bit too complicated, so we just forget it and push it off to the side. But now we can run a batch job across all of that data and start to parse it and start to get new insights from it, and that's really exciting for us. I mean, in New Zealand, again, I don't know what it's like in Australia, but we have really structured data fields around medications and diagnoses, so it's not really a big use case for us, but something that we think could be really useful is to search through the text and pick up some perhaps unclassified diagnoses, or to present the possibilities for uncoded diagnoses in the clinical record, and to do some kind of gap analysis work there, and that obviously has implications for funding, etc. That's the other part of that slide. QuickSight is the visualization tool. We've had a bit of a stake in using Power BI, which I'm not super keen on personally, but it's done a really good job of just exposing data to people that need to access it. QuickSight now has this anomaly detection feature built into it, which for me is like this is the thing you want to do with BI or regular business reporting, because you chuck all this data at clinicians and they say, oh great, I've got this data, but now what do I do with it? It's just there's lots of data points, I can't understand it. You really want them to go straight to a point of interest, so they don't have time to sit around and play with all the filters. So this automatically looks through time series data and says, this looks like an anomaly. And you can go straight to that data point. You can say, okay, on, I don't know, May the 1st, whenever that was, there was a higher than expected number of presentations at Thames Hospital. That's really useful. But additionally, you can go to the underlying causes of that anomaly. So you can say, okay, I've gone from a really kind of dense time series graph, and I've gone now to a detail level where I can say, on the 5th of May, whatever it is, there was a higher than expected number of presentations at Thames Hospital, and it was primarily driven by female inpatients to general surgery. So you've gone right from a very high level to a very detailed level, and you can actually do something with that information. So we're really excited about the possibility of that for helping people get to information that's useful to them as quickly as possible. We talked about openness and accountability earlier, but we published the whole code for this, for our whole thing on GitLab. And we're sharing this with our partners in the health sector in New Zealand. I mean, anyone can access it, but it's reasonably specific to New Zealand and the way that we access data from our ministry. But this has a number of advantages for us. Number one, we can share it and we can enable other people to get on board with what we're doing and to see all those advantages. But secondly, it's also a tool where the ministry have actually come to us and said, well, we need some oversight of what you're doing in the cloud. data. So now they can actually, this is a bit kind of mean, I guess, in a way, because well, the YAML template's there, you can go and read it, and you can see everything that we're doing with security, and they can actually see it. I mean, it's not as helpful as it could be, I guess, but it's there, it's on the internet, you can read it, and you can see how we're managing user permissions. So that's a really good thing. What's next for us? So I mentioned the 8-wire tool earlier, so we're going to roll that out across our network, and we're going to get direct connections from our practices to get data and land it straight into S3, integrate it into our data lake. We need to do a little bit more now. Our data is accumulating around archiving and lifecycling that data. We want to, well, we touched on Alexa and QuickSight before, but we want to start providing more tools directly to our clinicians, because they're the people that need to really get the advantage of this stuff. Integrations, that's the patient-generated health data I mentioned before. And a really exciting thing, I don't know if any of you are interested in popping over to New Zealand in November. It might be a bit warmer then, but we're having a digital health week, so this is our big health IT conference in New Zealand. And we're actually, as you can see, we're having AWS are co-sponsoring it with us and 3 other big primary care networks. So we're having a huge primary care focus, and we're having a huge focus on cloud tools and technology, and we're building quite a large experiential zone where we'll hook up lots of AWS services to try and create some nice scenarios for doing the kinds of, I was going to say of the future, but that sounds a bit grandiose, but we're going to do some really good stuff. So if you can make it, you'd be very welcome. And that's it from us. Thank you.